Now there is another property which is very important in logarithm, and that is a to the power log x to the base a. Now when we have this same number here and same number at base, then this is simply x. Basically it's a cancellation of inverse functions. So composition of inverse function with the function is always an identity function, which is x. So say for example, if I have 2 to the power log x base 2, so I have this number 2 and I have this base 2, so I'll simply write it as x. Now what if I have this? Suppose I have 9 log x base 3. Now I can write this 9 as 3 square log x base 3. Now I can raise this 2 to the power of x. So this is 3 and log x squared to the base 3. Now exponent and base, they are same, so I'll cancel it. So I'll get this as x square. So let us take an example. So the question is 9 to the power 1 plus log x base 3 minus 3 1 plus log x base 3 and minus 210 equals 0. So I can write it as 9 into 9 to the power log x base 3 minus 3 into 3 to the power log x base 3 and then minus 210 equals 0. Now I can again write this 9 log x base 3 as 9 and this is 3 square log x base 3. This is 3 log x base 3 minus 210. So again I can take this 2 to the power of x. Now I can cancel 3 with log 3, 3 with log 3. So I can write it as 9x square minus 3x minus 210 equals 0. I can divide by 3 also. So I'll write 3x square minus x 70 equals 0. So I can factorize it as 3x square minus 15x plus 14x minus 70 equals 0. So this is 3x plus 14 x minus 5 equals to 0. So value of x is minus 14 by 3 or value of x is 5. Now when I see this log, I know x cannot take a negative number. So value of x cannot be minus 14 by 3. So the answer to this question is x equals 5. Now another property is we can write a to the power log b base c as b to the power log a base c. So basically if I'll interchange this a and b, then the result will be same. So there will be no change. Now how do we do that? Say for example, I'll say let this is y. Now I'll take log both sides to the base c. Now power of a, we can take it out. Now I can take this number, I can also write it as log. Now I can take this number to the power of b. Now I can cancel log with log, so I'll get y as b to the power log a base c. That is a to the power log b base c is same as b to the power log a base c. So if I'll interchange a and b, there will be no change. So let us take up an example. So the question is 7 to the power log 5 base 3, 3 to the power log 7 base 5, minus 5 log 7 base 3 and minus 7 log 3 base 5. Now when I interchange 7 and 5 to the base 3, I'll get 5 and 7 to the base 3 and with a minus sign, so that means first and third expression will cancel. In the same way, when I say this 3 7 to the base 5, 7 3 to the base 5 and with a minus sign, it will also get cancelled. So answer to this question will be simply 0. So this is how we use this property. Now the question is simplify 4 to the power 5 log 3 minus under root 6 to the base 4 root 2 and minus 6 log root 3 minus root 2 to the base 8. So what I'll do is, first of all, I'll try and fix the bases. So I can write this as 4 and this is 5 log. Now 4 is 2 square and root 2 is 2 to the power 1 by 2. So if I'll add the powers, I'll get 2 to the power 5 by 2. So this is 2 to the power 5 by 2 and the number is 3 minus under root 6 and then minus 6. This is log. I can write 8 as 2 cube and this is root 3 minus root 2. Now I'll use the property where I can take exponent of base out. So it'll come in the reciprocal. So I'll write 5 upon 5 by 2 log 3 minus root 6 to the base 2 and then minus 6 by 3 log root 3 minus 2 root 2. So here 5 will cancel, here 2, here I'll get 2. So I'll get this as 2 log 3 minus under root 6 minus 2 log root 3 minus root 2. So I can take this 2 common. So I'll write this as 4 and this is 2. Now this is log m minus log n, which is log m by n. Now from the numerator I can take root 3 common. So if I take root 3 common, I'll write this as 2 log and here I'll write root 3 minus root 2 and this also is root 3 minus root 2, so it'll get cancelled. So I can also write this 4 as 2 square. So if I write it as 2 square, I'll get this as 2 to the power 4 log root 3. So now I can take this 4 to the exponent of root 3. Now here the number is 2 and the base is also 2, so it will cancel. So answer will be under root 3 to the power 4, and which is 9. So one of the most important properties in logarithms is base changing property. We can change the base of logarithm if we want, and the property is log b base a, and there is some number c which is greater than 0 and which is unequal to 1. I can write it as log b base c upon log a base c. So log b base a can be written as log b upon log a to some valid base c. Now say for example, I have log 7 base 5. Suppose I want to change it to base maybe 10. So I can write it as log 7 base 10 upon log 5 base 10. Suppose someone else wants to change it to base e. They can write it as log 7 base e log 5 base e. Suppose I want to use 0.1 as base. So I can also write it as log 7 to the base 0.1 log 5 to the base 0.1. So if I want, I can change the base of any number. And then from this property, I can also write it as 1 upon log c base a upon log b base c, and I can write this as 1 upon log a base b. So log b base a is reciprocal of log a base b. So now how do we get this property? So what I'll do is, I'll start with, I'll let this as log b base c as some x and log a base c as some y. Now I can write this b as c to the power x, and I can write this a as c to the power y, right? So now I need to express b in terms of a. So I can write c as a to the power 1 upon y, and I can put the value of c here. I can write b as a to the power 1 upon y to the power x, which is b is a to the power of x upon y. So if I take log to the base a, I can write log b base a is log a to the power x upon y. Now I can take this power out, so I can write it as log b base a equals x upon y. Log a base a is 1. Now x is log b base c and y is log a base c. And that is how we can prove this property, right? Now the question is given that log 3 to the base 2 is a, log 5 to the base 3 is b, and log 2 to the base 7 is c. Now we need to express logarithm of the number 63 to the base 140, 63 to the base 140 in terms of a, b and c. So that is, I'll need to find log 63 to the base 140. So first I'll use base changing property. So I'll change the base to 3. So I can write it as log 63 to the base 3 and log 140 to the base 3. So I can express it in prime power. So this is 3 square into 7. And this is 7 into 5 into 4. So now I'll use the property of log m into n, which is log m plus log n. So I can write it as log 3 square plus log 7 to the base 3, log 7 to the base 3 plus log 5 to the base 3 and log 2 square to the base 3. So now I can take these powers out. And log 3 base 3 is 1. So I can write it as this is 2 plus log 7 base 3 log 7 base 3 plus log 5 base 3 plus 2 log 2 base 3. Now we need to find log 7 base 3. Now what I know is I can write log 7 base 3 as log 7 base 2 upon log 3 base 2. Now I can also write log 7 base 2 as 1 upon log 2 base 7, and this is log 3 base 2. So log 3 to the base 2 is a and log 2 base 7 is c. So this is 1 upon ac. So log 7 base 3 is simply 1 upon ac. Now what about log 5 base 3? Log 5 base 3, it is given as b. So log 5 base 3 is simply b. Now log 2 base 3 is 1 upon log 3 base 2 and log 3 base 2 is simply a. So it is 1 upon a. So now I can write the value as, so this is 2 plus, now log 7 base 3 is 1 upon ac. So it is 1 upon ac. Here also it will be 1 upon ac. Now log 5 base 3 is simply b, and then plus 2 into log 2 base 3. Log 2 base 3 is 1 by a. So there will be 1 by a. So if I'll take LCM, I'll get this is twice ac plus 1 upon ac. And here again, I'll get the LCM as AC. So there'll be 1 plus ABC plus 2C. So answer to this question will be twice AC plus 1 upon 1 plus ABC plus 2C. Now question number 2 again is very simple logarithmic question, and it says we need to simplify the value of 1 upon 1 plus log c upon a to the base a square b plus 1 upon 1 plus log a upon b to the base b square c plus 1 upon 1 plus log b by c to the base c square a. Now we know that log a base a is 1. So what we'll do is we'll write this 1 as log a square b to the base a square b, and this is plus log a square b c upon a. Now we'll simplify this. We can write this is 1 upon, and will be log base is a square b. Now here we will multiply them, a will cancel, so we'll get this as abc. So we can actually write this as log a square b to the base abc. Now similarly for the second one, we can write this as log b square c to the base abc. And in the same way, we can write this third one as log to the base abc, and here the number is c square a. Now log m plus n is log m into n. So we'll multiply, we'll get log, and this is abc. Now here we have a square and a cube, b cube and c cube. So it will be simply abc cube. So we can take this power out. So then it will be 3 and log abc to the base abc, and log a base a is simply 1. So answer to this question is simply 3. So the value of this expression is 3. So the question is log 24 base 2 upon log 2 base 96 minus log 192 base 2, log 2 base 12, and we need to find the value of this expression. So what I know here is the base of these two logs, it is 2, but then here the base is 96 and 12, but here the number is 2. So what we know is log b base a is 1 upon log a base b. So if I take the reciprocal of this log, then I'll get the base as 2. So I'll write it as, so this is log 24, and 1 upon log 2 base 96 is log 96 to the base 2. 96 to the base 2 minus, and this again is log 190 to the base 2, and if I take reciprocal again, I'll write it as log 12 base 2. Now I'll express each of this number as prime powers. So 24 is 2 cube into 3. This is 2 to the power 5 into 3. Two square into 3. Now each of this expression is log m into n. So I can write it as log 2 cube plus log 3 log 2 to the power 5 base 2 plus log 3 log 2 to the power 6 plus base 3 and log 2 square plus log 3 base 2. Now here I can take these power out, and then for each of this log 2 base 2 will be 1. So I can write it as 3 plus log 3, 5 plus log 3, 6 plus log 3, and 2 plus log 3. Now I'll start multiplying them. So I'll get what? 15. Now 5 plus 3, 8. And then this is log 3 base 2 whole square, and then minus, I'll also multiply these two. So this is 12, 6 plus 2, 8. And then log 3 whole square. Now this 8 log 3 base 2 will cancel, and then log 3 also will cancel. So I'll get 15 minus 12, which is 3. Answer to this question is simply 3. Now the question is, if x is 1 plus log bc base a, y is 1 plus log ca base b, and z is 1 plus log ab base c, then prove that xyz is equal to xy plus yz plus zx. Now what I'll do is, I'll take up this x, which is 1 plus log bc base a. I can write this 1 as log a base a. So I'll simply write it as log a base a plus log bc. Now this is log m plus logn. So I'll write this as log abc to the base a. Now base changing property says I can also write it as 1 upon log a to the base abc. So if I'll interchange these two numbers, it becomes its reciprocal. So I can write it as log a base abc is 1 upon x. In the same way I can write log b base abc is 1 upon y, and log c base abc is 1 upon z. So if I'll add them up, I'll get log a, log b, log C as 1 upon x plus 1 upon y plus 1 upon z. Now this is log m plus log n, which is log m into n. Now log a base a is 1, so I'll get 1 equals 1 upon x plus 1 upon y plus 1 upon z. If I'll take reciprocal and if I solve it, I'll get the result as xyz equals xy plus yz plus zx. Now the question is, find the roots of the equation log x base 3 into log x base 4 into log x base 5 equals to log x base 3 into log x base 4 plus log x base 4 into log x base 5 plus log x base 5 into log x base 3. Now what I see here is, I see different base, but then the number here is same. So what I know is, if I'll take the reciprocal, then I'll get the same base. Now there will be two cases. Case 1, when x is equal to 1, and case 2, when x is unequal to 1. Now because when x is equal to 1, log 1 will be 0. So I'll get 0 is equal to 0. So that means x equal to 1, it satisfies the equation. So one of the root of this equation is x equal to 1. Now when x is unequal to 1, then I can use this x as my base. So I can write it as 1 upon log 3 base x, 1 upon log 4 base x, 1 upon log 5 base x, and this is 1 upon log 3 base x into log 4 base x, log 4 base x, log 5 base x, and this is 1 upon log 5 base x into log 3 base x. Now if I take reciprocal, I'll get this as 1 equals 1 upon log 5 log 3 and log 3 and log 4. Now this is log m plus log n, which is so if I take anti-log, I'll get x as 60. So the roots of this equation are either the value of x is 1 or the value of x is 60. Now in question number 10 it says, if x, y, z are positive real numbers such that x to the power 12 equals y to the power 16 equals z to the power 24, then if these three quantities are in AP, we'll need to find value of n. Now it is given that x to the power 12 equals y to the power 16 equals z to the power 24, and this is equal to sum k. Now we'll take log, say to the base e, we can write log x into 12 is equal to 16 into log y, and this is 24 into log z, and this is some log k, and this log k is some other constant, say c. So from here we can write log x is c by 12, log y is c by 16, and log z is c by 24. Now we can write log x base y. So we know that log x base y, we can write it as log x upon log y using base changing property. So log x upon log y will simply be 16 by 12. In the same way, log y base z, so it will be log y upon log z, which is c by 16 upon c by 24, so it will be 24 upon 16, and log z base x will be log z upon log x, which will be 12 by 24. Now the question says these three numbers, they are in AP. So that means we can write 8 log y base z is equal to 3 log x base y plus n log z base x. So it will be 8. Now log z base y, it is 24 by 16. X base y is 16 by 12, and then plus n and log z base x, so it is 12 by 24. So it will be 2 and 12, 4, and it will be 4, and then it is 2. So from here we can write n by 2 and it is 12 minus 4 which is 8. So value of n is simply 16. So answer to this question is 16. Now in question number 7 it says there are 3 numbers a, b and c and each greater than 1 such that 2 by 3 log a base b plus 3 by 5 log b base c plus log c base a 5 by 2 is equal to 3, and it is given that if the value of b is 9, we need to find value of a. Now what I'll do is I'll write arithmetic mean for these 3 numbers. So for these 3 numbers, arithmetic mean is given by 2 by 3 log a base b plus 3 by 5 log b base c plus 5 by 2 log c base a whole divided by 3. Now in the question it says sum of these 3 numbers is 3. So 3 divided by 3 is simply 1. So arithmetic mean of these 3 positive numbers is simply 1. Now what about their geometric mean? So their geometric mean will be 2 by 3 log a base b into 3 by 5 log b base c into 5 by 2 into log c base a to the power 1 by 3. Now here 3 will cancel, 5 will cancel and 2 will also cancel. Now this log a base b, it is simply log a upon log b. This is log b upon log c and this is log c upon log a. So here also everything gets cancelled. So geometric mean for these 3 numbers is also 1. So that means I'm getting this condition where arithmetic mean is same as geometric mean for these 3 given numbers. Now we know that arithmetic mean is equal to geometric mean only when all the numbers are equal. So that means the condition I'm getting is this 2 by 3 log a base b is equal to 3 by 5 log b base c is equal to 5 by 2 log c base a. Now what I'll also do is I'll change everything to the base 3. So I'll write 2 by 3 log a base 3 upon log b base 3, 3 by 5 log b base 3 upon log c base 3, and this is 5 by 2 log c base 3 upon log a base 3. Now this log b base 3 is actually log, now value of b is 9 and 9 is simply 3 square. So log b base 3 is 2. So I'll put the value of log b base 3. So I'll write it as 2 by 3 log a base 3 upon 2. This is equal to 3 by 5 and this is 2 upon log c base 3 and this is 5 by 2 log c base 3 upon log a base 3. Now if I'll simplify these first 2 expressions, then from here I'll write log a base 3 into log c base 3 and this value will be equal to 18 by 5. Now if I'll take this first one and third one, from here I'll write log a base 3 whole square upon log c base 3 and this value will be equal to 15 by 2. Now I'll multiply these two. So if I'll multiply them, then I can write it as log a log c into log a whole square upon log c, and this is 18 upon 5 into 15 upon 2. Here log c will cancel, so I'll get log a base 3 whole cube, and this is equal to, so this is 9 and this is 3, so it'll be 27. So from here I'll write log a base 3 is equal to 3. So if I'll take anti-log, then I can simply write value of a is simply 27, and that's your option number D. Now we'll discuss problems based on characteristic and Mantissa. Now what we know is any number x can be expressed as a sum of its integral part plus sum of its fractional part. So I can write any number x as n and plus f, where this n, it belongs to integer, and this f, it's a positive number which lies between 0 and 1. Any log is just another number. So I can express log b base a as n plus f. This integral part is called as characteristic, and this fraction part, which should lie between 0 and 1, is called as its Mantissa. Now say for example, suppose I have log 875. If you'll find this value, you'll get this value as 2.942. So I can write it as 2 plus 0.942. So this 2 is your characteristic and 0.942 is its Mantissa. Now say for example, if I'll take log 0.123, you'll get this value as minus 1.91. So I can write it as minus 1 minus 0.91, but then the fraction part should be positive. So actually I can write it as minus 2 plus 0.09. Now in this case, characteristic is minus 2 and Mantissa is 0.09. So there will be many questions which are based on characteristic and Mantissa. Now the question is, find the number of digits contained in 875 to the power 16. Now what I'll do is, I'll write this as some number x, and I'll write this as 875 to the power 16. I'll take log both sides to the base 10. I'll take this power out. So I'll write this as log. I'll take this 16 out. This is 16. And I'll write this as log 5 cube into 7. So I can write it as log x base 10. And this is 16. So I'll use log m plus log n. Now I can write 5 as 10 by 2. Now log m minus log n, so this is 3. Log 10 is 1 minus log 10 base 2 and plus log 7 base 10. So this is 16 and this is 3. 1 minus log 2 is 0.3010 and plus this is 0.8451. So this value is 16 into 2.9421, and if I'll multiply it with 16, I'll get this as 47.07 something. So 4707 something. So I can write it as log x to the base 10 is 47.07. So now if I take anti-log, I can write this as x as 10 to the power 47.07, and this is 10 to the power 47 into 10 to the power 0.07. Now 0.07, it actually lies between 0 and 1. So I can write it as 10 to the power 0. So 10 to the power 07 will lie between 10 to the power 0 and 10 to the power 1. So which is this value. It lies between 1 and 10. So it is a number between 1 and 10. So that means I need to add one more digit to 47. So number of digits in 875 to the power 16 is 47 plus 1, and which is 48. So now the question is, if log 3 base 10 is 0.4771, find the number of zeros after the decimal in 3 to the power minus 100. So again what I'll do is, I'll take this as x. Now I'll take log both sides to the base 10. I can take this number out. So this is log x base 10 minus 100 and log 3 base 10 is 4771. So I can write it as log, and this is minus 47.71, and I can also write it as minus 48 0.29. So I can express it as x equals 10 to the power minus 48 plus 0.29, which is x to the power 10 to the power minus 48 into 10 to the power 0.29. Now again 10 to the power 0.29, it will be a number which will lie between 1 and 10. I'll add 1 to it. So number of zeros before the decimal will be 48 minus 1, and there will be 47. Now the next question is, find the number of positive integers which have the characteristic 3 when the base of log is 7. So what we know is we are looking for all the numbers for which if I take log to the base 7, then its characteristic should be 3. So that means the value of log x base 7 should lie between, so if I take anti-log, I can write as 7 to the power 3, and this is x, and this is 7 to the power 4. So therefore the number of such integers is given by 7 to the power 4 minus 7 to the power 3, which is 7 to the power 3, 7 minus 1, 6 into 7 to the power 3, which is 6 into, which is 2058. If p is the number of integers whose logarithm to the base 10 have the characteristic p, and q the number of integers the logarithms of whose reciprocals to the base 10 have the characteristic minus q, then compute the value of log p base 10 minus log q base 10 in terms of p and q. Any number whose characteristic is p to the base 10, I can write it as log, suppose the number is n1 and the base is 10, so its value should lie between p and p plus 1. So if I'll take anti-log, I'll write, so this is 10 to the power p n1, and this is 10 to the power p plus 1. So the number of such integers, which is capital P, will be given by 10 to the power p plus 1 minus 10 to the power p. I'll take 10 to the power p common. I'll get what? 10 minus 1. So it is 10 to the power p into 9. Now that's your first part. Now for the second part, it says the number of integers, the logarithm of whose reciprocals to the base 10. So that is, I'll take suppose log 10, and this is 1 upon n2, and says has characteristic minus q. So if it is minus q, so I'll write it here minus q, and here will be minus q plus 1. So I can write minus q. Now 1 upon n2 is n to the power minus 1, and I can take minus 1 out. So this is minus n2, and this is minus q plus 1. So if I'll multiply with the negative number, then sign of inequality reverses. So this is q, and this is n2, and this is greater than q minus 1. So if I'll take anti-log, I'll get 10 to the power q n2, and this is 10 to the power q minus 1. So therefore the number of such integers is given by 10 to the power q minus 10 to the power q minus 1. So I'll take 10 to the power q minus 1 common. So again I'll get 10 minus 1. So there'll be 10 to the power q minus 1 into 9. Now we'll need to find the value of log p minus log q. So log p minus log q, I can write it as log p by q. So there'll be log, and p is 10 to the power p into 9, and this is 10 to the power q minus 1 into 9. 9 and 9 will cancel, so I can write it as log 10 to the power p minus q plus 1. Now I can take this power out, and log 10 base 10 will be 1. So there'll be p minus q plus 1. So answer to this question will be p minus q plus 1. Now question number 18, it says let Pn be number of digits when 8 to the power n is written in base 6, and let Qn be number of digits when 6 to the power n is written in base 4. We'll need to find this limit, which is limit n tends to infinite Pn Qn upon n square. Now there is a direct formula for that. So if we write 8 to the power n to the base of 6, then number of digits Pn, it is given by greatest integer function of log 8 to the power n to the base 6 and then plus 1. So this is the formula to find out number of digits in other base. So in the same way, we can find number of digits Qn when the base is 4. So Qn will be log base is 4 and number here is 6 to the power n and plus 1. So basically Pn is n log 8 base 6 plus 1, and Qn is greatest integer n log 6 base 4 plus 1. Now we need to find this limit, which is limit n tends to infinite Pn into Qn upon n square. Now in greatest integer function, we know this property that greatest integer function of x is always less than or equal to x, and it is greater than x minus 1. So I can write Pn is less than or equal to n log 8 base 6 plus 1, and it is greater than n log 8 base 6. In the same way, we can write Qn. So Qn will be less than n log 6 base 4 plus 1, and here will be n log 6 base 4. Now if we multiply them, then we can write it as n square log 8 base 6 into log 6 base 4 is less than Pn into Qn, and it is less than n log 8 base 6 plus 1 into n log 6 base 4 plus 1. So now I'll need to find this limit. So I'll need to divide it with n square. So I'll also divide it with n square. So if I'll divide it with n square, and I'll take this limit also. I'll take this limit n tends to infinite. Now since it is an infinite limit, so highest power of n in the numerator and denominator is 2. So answer to this left hand limit will be simply log 8 into log 6, and here it is limit n tends to infinite Pn Qn by n square, and here also the highest power is n square. So here also this limit will be log 8 base 6 into log 6 base 4. Now Sandwich theorem says if fx lies between gx and hx, and if limiting value of gx is L and limiting value of hx is L, then the limiting value of this limit is also L. So which simply means the value of this limit is equal to log 8 base 6 into log 6 base 4. So I can write it as log 2 base 8 upon log 6 base 2, and here will be log 6 base 2 upon log 4 base 2. So it will cancel. So 8 is 2 cube and 4 is 2 square. So the value of this limit is simply 3 by 2, and that's your option number C.